flow specifications. So there are two separable parts of flow specs. So there are two separable parts of the flow spec. One is called TSpec, and this basically identifies flows traffic requirements. And the second type of flow specs is RSpec. And RSpec basically it provides the service requested from, or identifies the service that is requested from the network. So it identifies the service requested from network. This basically specifies our delay target or bound. So this specify delay target or bound that a service has to follow or provide. So this T spec is a little more complicated, right? So because we need to know the bandwidth of our sources, and the bandwidth of our sources varies all the time. So what I want to say is this T spec is more complicated. Why? Because we need to know the bandwidth of our sources, and bandwidth sources varies with time, because bandwidth sources varies with time. So in order to identify the bandwidth sources, and the bandwidth sources are the bandwidth characteristics of our sources, we will be using token bucket filter. Token bucket filter. All right. So so this token bucket filter is a way to decide or to describe the bandwidth characteristics of sources. So is one way to decide bandwidth characteristics of our network sources. Okay, so such a filter can be described by two parameters. So token bucket is a filter that will help us to address this problem of key specification being more complicated, and it decides the characteristics of sources. And such a filter is described by two parameters. So it is described by two parameters. One is called, number one, token rate. token rate, say R, and number 2, a bucket depth. A bucket depth, say T. So we will be using these two parameters to see how it works, right? So the question is how it works, how this token bucket filter works and identify the characteristics of a network sources, right? So to be able to send a byte, we must have a token. So the first requirement is, if we want to be able to send a byte, we must have a token. So if I start with no tokens, then I accumulate them at the rate of R per second. So what if I don't have a token to start with? So what I'll do is I will accumulate token. I will accumulate tokens at a rate of, obviously, R per second. Right. So this means that I can send a burst of as many as B bytes into the network as fast as I want. So this means I can send a burst of as many as B bytes. Why B? Because B is the depth of the bucket. B bytes into the network, and that too as fast as I want. Okay, but keep in mind that over a sufficiently long interval, I cannot send more than R bytes per second, right? So this means I can't send more than R bytes considering a sufficiently long interval. So it turns out that this information is very helpful to admission control also, right? So it turns out this information is very useful or helpful, is very helpful to admission control algorithm as well. Right. Why? Because it tries to figure out whether it can accommodate a new request for service or not. So this is also the functionality of an admission control algorithm. Let's try to understand these steps with the help of an example that how the token bucket filter works and how we can classify or identify the type of network traffic with the help of this example. We have bandwidth in megabytes per second, and on this x-axis we have time in seconds. So we have 1 second, 2 seconds, 3 seconds, and say 4 seconds. 1, 2, 3, 4, and likewise we have 1 megabytes per second, 2 megabytes per second, and 3 megabytes per second. So let's assume that, we have a flow that continuously generates data at 1 megabits per second, right? So let's call it flow A. So this means for flow A, what is R? What is the R? Yes, 1 megabytes per second, and a bucket depth of 1 byte. So what is B? 1 byte means it cannot store more than 1 token. So this means it sends them immediately. So that's why. So we have a flow where the rate is 1 megabytes per second, and the depth of the bucket B is 1 byte. This means it cannot store more than 1 token. So this means it cannot store more than 1 token. So that's why it sends all the tokens or bytes immediately, and the sending rate is 1 megabytes per second during this time interval. But let's talk about the other flow. Let's assume that we have a flow B that sends at a rate that also average out to 1 megabytes per second, but it does so by sending 0.5 megabytes per second for 2 seconds. So what it does is it sends 0.5 megabytes per second for 2 seconds, and then send data at say 2 megabytes per second for 1 second from 2 to 3 seconds interval, right? And then it again sends data at 0.5 megabytes per second, right? But this means unlike flow A, flow B needs a bucket depth B of at least 1 megabyte, right? So only then we will be able to send data at 2 megabytes per second for 1 second from 2 to 3, right?